Hello everyone. I am delighted to have this opportunity to share our findings and insights on vision-based 3D object detection. Today I will introduce our work, Object as Query, lifting any 2D object detector to 3D detection. The goal of vision-based 3D object detection is to classify objects and localize them using 3D bounding boxes given multi-view RGB image. Previous methods mostly adopt either dense BEV representation or sparse object queries for 3D object detection. Dense BEV representation project image features into BEV space and obtain dense BEV features, which implicitly encode object information. However, the computational costs are squarely proportional to the range of 3D space, encountering difficulties in scaling up to large-scale scenarios. Another group of methods adopt sparse object queries distributed in 3D space to represent objects. Although fixed number of object queries avoid computational cost exploding with 3D space, the query number and position relied on empirical prior may cause false positive or undetected objects in dynamic scenarios. Our contributions can be summarized as: we propose a framework that can lift any 2D object detector to multi-view 3D object detection. We demonstrate that dynamic object queries and aggregation from certain relevant regions in images based on 2D detection can boost 3D detection performance. The framework of the proposed MV2D. Given the input multi-view images, image feature maps are extracted by a feature extractor. Meanwhile, a 2D detector is used to obtain per view 2D detection results. Dynamic Query Generator takes object features, 2D detection boxes and camera parameters as input to initialize a set of object queries. ROI align is applied to the object regions to obtain the fixed-length object features for Query Generator. All the features fallen in the object regions are decorated with 3DPE. Then the object queries and object features are input to a decoder to update query features. Compared to Valina Transformer Decoder, the decoder in MV2D employs sparse cross-attention where each object query only interacts with its relevant features. Lastly, a prediction head is applied to the updated object queries to generate 3D detection results. The dynamic query generator derives a 3D reference point in 3D world space for each ROI. Then the object query is generated from the reference point by a positional encoding layer. Specifically, we first obtain the equivalent camera intrinsic for each ROI. Then we encode the object location based on the ROI feature and the equivalent camera intrinsic. Each object is only captured in a sub-region within the multi-view images. By focusing on the relevant region with respect to a target object, we can eliminate the distractors and noises that may hinder the object localization performance. To this end, we propose a relevant object feature selection method to obtain relevant regions for each object query. We project the generated 3D mesh grid of each ROI to other views. And the bounding boxes in other views that overlap with the projected mesh grid are selected as relevant regions. We provide a detailed analysis of MV2D in the ablation study, which verify the design choices of dynamic object query generation and relevant object feature selection. We also compare the proposed method with state-of-the-arts in Nusine's dataset. The experiment results indicate the effectiveness of our method. Thank you for watching.